SIPA. Sam, please report to the stage. Are you on at 3? Isn't that 3? Yeah, come on up. Where's Jack? Jack Armstrong. Oh, hi. Sam, Jack is waving you. Well, it's my honor to introduce my idol and an incredible friend. And if you haven't figured this out yet, if you've been in this room with me, I mean, I wish I could go to all the sessions because they're all incredible. The great news is we're recording all of the sessions, so you'll be able to access them online, take them back with your team and get a chance to see them. In this particular hour, there are some incredible sessions. Not that it's not everyone, but I always tell Sam that, I mean, Sam has been my idol for so long, and what he's done to push high performance home building across the United States and Canada, for that matter, Sam, is absolutely incredible. And then I've gotten a chance to know Jack Armstrong through SIPA and through being on the board of Team Zero and now the board of EEBA. And I couldn't be more excited. The topic of their presentation is faster, better, and cheaper. And I don't know about all of you, but my grandfather was a builder in Minneapolis. And what he told me was faster, better, cheaper. They're in a triangle. You can pick 2, but you can never have 3. And I believe that Sam and Jack are going to dispel that myth today. So please help me welcome Sam Rashkin and Jack Armstrong.
We'll do a survey at the end and see if you all agree with Aaron. You only could do 2 or you can do 3. How's that sound? By the way, how many were at the last session that just proceeded? A bunch. Okay, good. So let's see if this is forward. Okay, let's talk about the title. This is a session called High Performance Home, Faster, Better, and Cheaper. And what we want to do is team up Jack and I. Jack has a horse in the race. He's the executive director for the Structural Insulated Panel Association. And I'm Sam Rashkin. I'm a free spirit. I'm promoting other things. So the 1-2 punch is I'm going to give you my unobjective view of getting to high performance faster, better, and cheaper from 27 years, I hate to say, running national programs, visiting tens of thousands worth of homes, engaging thousands of builders. And just after seeing the depth and breadth of what we're doing and the success moving to high performance, why aren't we doing what is faster, better, cheaper? So let's start with first, what I'm doing right now very quickly is I've seen so much opportunity to optimize the housing industry that's not being done. And so what I did was compile everything I thought we've learned from 5 years of research with hundreds of builder executives working on this concept of just optimization and taking the industry to the next level and put it in a book. And it's the context for a lot of what you're here today. But the goal of this is to, how do we position high performance home builders, professionals, architects, program managers to be the most successful in the country by not just being focused on high performance, but on the total user experience for the ultimate consumer product. One of my favorite builders wants to do some work together, and I went to look at our website, and there it is right in the first page, Zero Energy Ready Home Builder. And I was so frustrated because I'm so excited that she was really wanted to do that program. I'm going, that should not be your story. It's too limiting. There's a total experience buyers expect. So this is the context. It's over 400 pages. It's got hundreds of graphics. The first book I wrote had 60 citations. This one has over 360. It's a lot of research, and it's a lot of guidance how to do high performance for better, for less cost. So the outline of what we're going to cover is we'll look at the power of innovation. Innovation is transformative, done right. And then we'll look at high performance home enclosure innovation and suggest maybe it's time to rethink it. But then we'll look at the next part, the challenge, getting that high performance home enclosure innovation to the market. It's great that it's better, but there's still some unique challenges you have. And then how we're attempting to look at it with structural insulated panels to communicate that innovation at the point of bidding to a builder in a more effective way of translating the value. And Jack's going to give you the state of the SIPs address about all the new and amazing things they've done to make SIPs more accessible. So that's what we're doing. And let's start with the power of innovation. And I always like showing these slides because they're so effective at showing innovation absolutely in front of your eyes in a way that it's hard to show. So you had two forms of transportation, personal transportation at the beginning of the turn of the century, 1900s. You could either use a horse and buggy, or you can use this newfangled thing called the automobile. And if you want to know which one out at the time, just look at a picture of New York City, 1903, Easter Day Parade, Fifth Avenue. And the Where's Waldo question is, where's the automobile in a sea of horse and buggies? And I'll highlight it for you right there. And so it was clear that for some reason, even though you had two options, the predominant, almost singular option that was chosen by consumers of transportation were horse and buggies. Fast forward 10 years, 1913, and Fifth Avenue, Easter Day Parade, the exact same street, picked in a picture 10 years later, and you flip the question to where in the sea of automobiles is the horse and buggy? Right there, and it's everything changed. And why did it change is two conditions are in play. First is you have a driving force for change. It's either a problem that needs to be solved and or an opportunity to really transform user experience. And then the second thing you need is, here's where the innovation comes in. You have an innovation that's a solution to the problem and or this amazing new user experience. Something like that happens, and it happens on steroids when the problem transitions to become a crisis. So let me show you something that drove me crazy. Very rarely do I scream at a TV set. This is one of the occasions. My wife and I are watching The Gilded Age on HBO. Many of you probably haven't seen the series, but it happens right at the turn of the century. And why was I screaming at the TV was, look at the pristine street in the turn of the century New York City. In fact, that is Hollywood myth. That is the furthest thing from reality. This is actually what was going on virtually in all big cities in Europe and all big cities in the US. you had a massive crisis, an environmental crisis of the time. In New York City's case, the problem was you had 100,000 plus horses producing over 2.5 million pounds of manure, probably the same amount of piss as well. It was just a nightmare. And you see this image from one of the newspapers at the time. And the result was living in cities was a horrid experience, visually, odor, and epidemic health issues that were going on. And so, clearly something was needed to be done. Unfortunately, the solution, the alternative at the time, 1903 automobile, sure, the automobile doesn't poop. We got that covered, but the user experience was horrible. It was really high cost for cars. They were cobbled together in a back room somewhere where a single person would put together the parts, and it was slow, clunky to use and awkward to drive, really high maintenance. If a part failed, good luck trying to get it fixed. It wasn't ready for prime time. And you all know what happened by 1913, the assembly line kicked in. That was the innovation that makes it happen. And so, yes, cars don't poop, and cost dropped 85%. The maintenance with all the standard parts and all the infrastructure to provide the services that you need, the enhanced durability with a completely engineered, mass customized solution. In fact, you can get any color you wanted as long as it's black, right? There you go. We completely transformed the market. So my key point about innovation is if you wait too long, if you don't adapt, you're left behind. So think of all the poor veterinarians and horse caregivers who were just left out of work. All the horse exchanges no longer had any business. There we go. All the horse and buggy companies that completely had to shut down. All the stock feed companies that lost business, the stables, the horseshoeing and jobbing businesses, and then the poor workers who were running around the streets cleaning up the mess. All those peoples were disrupted. And that was only part of the disruption, right? All the services around all those businesses, whatever shops and other services tied to it, all of that suffered if you didn't see this coming. And now we know we have the next disruption going to happen, right? Because now the new issue with cars is they emit carbon dioxide and emissions. And now we have a solution. Electric vehicles don't have emissions, and they have this incredible user experience, 60% lower cost for fuel, much lower maintenance, amazing drivability. Like they're on rails when you have those batteries all the way low and centered. Driving those cars is a completely different experience. The acceleration, the quiet, the safety. The self-driving cars are coming. And then very quickly, we're going to see wireless charging. Just drive right over the charger, much the way your cell phone goes into a wireless charger. Amazing, better experience. But of course, in the future, we're going to have to worry about landfill and all the batteries that come from these millions and millions of cars. But that's what happens. Things disrupt when you have a solution to the problem and an innovation that addresses the problem and improves the experience. So I'm going to suggest disruption is going to come to housing. And over the next 3 to 5 years, you're going to see some amazing changes. The reason I asked how many people raised their hand for who were here at the last session, Danielle and Jesse Younger, and what they're doing with this project with DigiBuild, Lago Place near Austin on Lake Travis. That's the whole shooting match. No, that's everything we're pointing to. It's going to address all these crises. There are 5 crises that are just hammering the housing industry. It's the lack of user experience readiness. It's the affordability, productivity, the lack of being digitized. It's going to address all these crises that are converging. And it has all these, by applying all these new innovations. It is an absolutely user experience optimized community. It's an absolutely user experience optimized house. It has fully optimized performance. It is fully digitized. It's mass customized. If you're not relating to some of these terms, you really need to go back and watch the recording about that project. That's the future. And so as a result, when I connect dots, I make this prediction that's the future with certainty. Okay, so Now I'm going to suggest in this room, I want to focus on the enclosure. I think that has to transform as well. It's stunning that we build a home enclosure with, thousands of different pieces of wood and connections and nails. It's just a stunning amount of complexity, risk. I just can't believe that we're willing to accept that. For those that see my other presentations, I showed the picture of the house under construction in 1877 in Nebraska, side by side with a house under construction today, and the stunning lack of innovation over 150 years. It's just amazing. So what I want to bring to bear to understand the value of going to innovation is to understand from a building science perspective, all the risk we manage when we go to high performance enclosures. Risk comes along for the ride anytime we ratchet up performance for any product. When you make it higher performing, usually there are a whole associated set of risks that you have to manage. By example, I can show you that when we started with airplanes and they open cockpits, they flew at low elevation, which is the vertical axis, and very low speeds, which is the horizontal axis. And then we said we want to make them higher performing. So you look at new modern jet transportation, it flies at 35, 40,000 feet above elevation. It flies at 500 miles per hour. So we added all this performance that makes them faster, better, and more comfort, but we took on amazing risks. We had almost no oxygen at 35,000 feet. So we don't not fly at 35,000 feet, we manage the risk. We have pressurized cabins and oxygen masks and so forth. We have 150 mile per hour winds and turbulence, so we build stronger frames and lighter frames. We have minus 70 degree Fahrenheit temperatures at 35,000 feet, so we have much more insulated enclosures for the cabins, and we have much more risk of collision with thousands and thousands of planes flying around at 500 miles per hour. So we have radar detection, collision avoidance, all these automated controls. We manage the risk for high performance air travel. I forget the number. I just researched the number of airplane accidents in the last 20 years or so, and it's like 1/400th of what car transportation are in terms of number of deaths per mile traveled. It's just a stunningly safe form of travel. We can manage risk. That's why we do it. So what about high performance enclosures? So a low performance enclosure, the axis vertical and horizontal change, the air tightness on the vertical and the thermal resistance on the horizontal. So when we have a low performance enclosure, we have low air tightness or high air leakage, and we have low thermal protection. But of course, we're going to go to high performance enclosures, right? Low bills, more comfort, health, durability, and safety. It would be insane not to do a high performance enclosure. But we have greater risk when it comes to moisture, comfort, and indoor air quality. So we do not do high performance enclosures. What we do is we manage the risk. So let's look at why the risk happen, what we do to manage it. So if it's a low performance enclosure, basically we have a lot of airflow and thermal flow going through the enclosure. If it's high performance, the one on the top, we have a tremendously reduced amount of airflow and thermal flow going through the enclosure. What that means is we have a cold surface, a much colder surface on the inside of the cavity on the cold side of the assembly. That's just logic, right? We're stopping the thermal flow from getting to it, it's much colder. We're stopping the warm air that leaks through from getting to it, it's much colder. So look at the risk. We have more wetting potential. That surface now is going to condensate much more quickly because it's much lower temperature, and we have less drying potential because we have less thermal energy getting through the assembly that can dry it out if it can get wet. We're doomed in a high performance closure if moisture can get in. It cannot dry anywhere near the way a low performance enclosure used to. The reason we can't retrofit 80 million existing homes by throwing in wall insulation is now we're creating a cold surface when we do not have the control layers to manage the moisture flow. And we'd be adding tremendous risk just by blowing the insulation in an existing home. We can do this in new homes because we can manage the risk, we can do our control layers. So that's what we do. We do the building science control layers. We do HVAC best practices to ensure that we're not having air leakage in ducts that can create problems, and we're managing humidity indoors better. And we have ventilation to dilute humidity indoors as well. So we just know how to manage the risk, and then of course we do it. The same thing when it comes to comfort, we have to realize that we have this new reality in high performance enclosures. They have ultra low heating and cooling loads, incredibly low, a tiny fraction of what they used to be. And therefore we have more risk. The risk comes from the fact we have less airflow that going through the comfort system, right? The ducts have much less airflow. We hardly engineer the ducts with diligence. The infrastructure just doesn't really spend nearly enough diligence on the duct design. We have shorter cycles to get to the cooling when the loads are so small. So the cooling coils are getting are not getting cold enough, long enough, the way they used to remove as much moisture. So what are we going to do about the latent load? And further with the latent load, we have these swing seasons that are so much longer on the front end and the back end when we don't have sensible cooling, but we still have humidity loads that require latent load to be managed. All this additional risk in a high performance enclosure. So what do? We do variable speed systems that can throttle down more effectively. We do HVAC best practices where we have quality installation. We don't have, we have ducts that actually design properly and have the right airflow and get the comfort to the room, even if it's a small amount of airflow. We have new innovations like plug and play ducts. We have dehumidification now as a must-have. It's not an extra credit any longer. And in the future, we'll have automated fault detection and diagnostics so we can manage and get ahead of any issues that may be happening with the HVAC system. Then on the IAQ side, we have this ultra low dilution since we have so much less air leakage. So that means we have greater risk with the contaminants that accumulate from all the ones we bring in, whether it's the furnishings that have fire retardant chemicals, whatever chemicals are involved in building materials, carpets that accumulate dust, the moisture that's generated indoors, cooking, cleaning, washing. We have all these contaminants, so we have to manage them. We do comprehensive building science again to control the airflow that will introduce external contaminants like pollen, dust, humidity. We have HVAC best practices to ensure that we have the ducts are airtight and can't introduce contaminants into our home. And we have comprehensive indoor air quality like Indoor Air Plus that has source control, dilution, which is ventilation, spot and whole house, and filtration. We manage the risk. Okay, and then future ready, by the way, we have homes when we do all this that are ultra durable. It should last for hundreds of years versus much shorter times. So we should manage the risk that they will stand the test of time, that they're future ready. And therefore we have to realize that we have much more propensity for disasters. The frequency and the magnitude of disasters is mind-blowing that we're watching every year. I think we had 6 1,000-year rainstorms in a 6-week period this year. That we have to recalibrate what is a 1,000-year rainstorm, right? Don't we? We have much more. The water shortages are historic. You know, we've been hearing about Lake Mead and just the whole western region of the country. What are they going to do about water? And we know that we're going to all electrification. We've heard that many times today. So we manage that risk by integrating resilience, both pre and post events, water conservation and drought prevailing locations. And we think about electric ready homes. You know, we have solutions, if we do include fossil fuel appliances or equipment where we have the electric connection ready to go. Solar ready is already part of zero ready home. Electric vehicle level 2 chargers and battery ready solutions where we can bifurcate loads that are critical, have the switches and so forth. All this we know we need to do. So this is where I come up with a high performance home full strategy. If it looks like what you've seen from Zero Ready Home, it's because it's all derivative of that. But essentially why we do this is better user experience homes are a must-have. Better for the homes, better for communities, better for planet. And then what we do is step one, we always start with efficiency. In every product, we have to first optimize efficiency. The enclosure the equipment, the components inside the homes. Step two, now we have all these risks that we take on with a high performance closure. They become must-have. The building blocks for water protection, because we have no tolerance if we get wet, ensured comfort with really diligent best practices for HVAC, and a comprehensive indoor air quality system. Then we're future ready, resilience, water efficiency, and electric ready. And finally, we're future ready. We're getting on the path to zero carbon, net zero energy ready, zero energy, net zero carbon. You can pick your step where you want to be, but start getting on that path. And what I want to focus on today is these two key parts. These will take you down in this whole system of building blocks for high performance homes. If you don't get the enclosure right, you can't replace the enclosure. And if it's not water protected, you can't fix it as well. So let's understand all the forces that we have to act to, and then see if you agree with faster, better, cheaper. So you all understand the basics. The second law tells us that we know the direction of flow. Everything goes from more to less. So air pressure wants to go to lower air pressure, and heat wants to go to lower heat, and higher moisture wants to go to lower moisture. We know the direction. And we also, therefore, see how that impacts our homes and the enclosure. For airflow, we have outside wind, higher pressure wants to get inside when it's lower pressure. Soil gases below grade that might, let's say, carry radon, want to get into your basement when it's lower pressure inside the basement. Inside the home, stack effect is putting this constant pressure right up against your attic at all times, and fans like clothes dryers and exhaust fans and clothes washers, all those exert and create negative pressures in our home. And then when it's hotter outside, it wants to get inside. When it's hotter inside than outside, it wants to go from inside to outside. We know the flow. And then bulk moisture wants to get inside where there's less bulk moisture, and moisture vapor wants to get from outside to inside, whether it's in the air or in the soil gases below. So these are all the forces that we have to manage. So building science is essentially 4 control layers to manage all those risk factors. We have the airflow control layer, we have the thermal flow control layer, we have the water flow control layer, and the vapor flow control layer. That's what building science is. Joe Stieberg's book says humidity is the absolute most important part of building science. So it's the moisture control handbook. That's why it's called that. But it's really a building science handbook, how to do all these 4 control layers. So your first and most important air control layer is the air barrier. This is a checklist of air barriers that you need to have. Essentially, this is the thermal bypass checklist we developed for the Energy Star Certified Home Program, version 2. And these are, you got to have them at all these locations. I'm not going to walk you through these. Just, there are lots of air barriers, and this checklist is critical because if you get it wrong, it will completely undermine the thermal performance of the enclosure. Then on airflow control, air tightness, these are all the targets for different programs by climate zone. Zero Ready, Energy Star version 3, 2012, IECC 2015 is the same, Passive House. So you have these ACH 50 targets. It's way too complicated. Let me make it simple for you. Everyone should be 1.5 or less, every climate zone. This is absolutely insane to go higher. We can build enclosures that are airtight. If for no other reason to keep dust, pollen, moisture out of our homes, even in hot, humid climates and in cold climates and all climates. We got to build to 1.5. So you got the spaghetti of different targets. I believe, particularly when we use the better enclosure systems, 1.0 will soon become the target. Then it comes to how do we get to that target? Well, in a typical construction, you have this is your basic usual suspects. This is the checklist for air sealing. You have the penetrations, you got to have half mile of cracks around windows, doors, and all these other key points. And then you have odd geometry creates all sorts of air sealing challenges you have to manage. One of the reasons I advocate simple is the geometry is really tricky in the field, but that's a separate issue. So there's your air sealing checklist. I'm not going to go through. We know these. But again, if you get air sealing wrong, this is the ultimate building science uh, um, way to building that doesn't work. If in real estate, it's location, location, location. In building science, it's air control, air control, air control. That's where you have to be. And what's interesting is the most egregious interface, the one that is going to really have the most potential exposure to risk, is the attic ceiling interface. The delta T across the attic ceiling interface is greatest because in the summer, the attics can get, right now, I'd assume in Phoenix today, your attic's running at least 160 and you're 70 in the home, you're looking at a 90-degree delta T. In the winter, the attic will be about the same temperature as the house. So it's the worst delta T you have. Then you have the stack effect, it's constant like 5, 10 CFM pushing right up against the attic. And you don't want, again, any potential for warm air to hit a cold surface. And you have all the air barriers we talked about. We have all the air leakage checklists we talk about. That, you know, the attic is like Swiss cheese, basically. You have duck boots, you have penetrations, you have hatches, you have recessed lighting, you have dropped and raised ceilings. I mean, it's just the worst when it comes to the number of penetrations and cracks. Just the drywall where it interfaces the top plate is hundreds and hundreds of feet of crack that you have to basically seal. And it's a very difficult seal. And then, of course, somehow the insanity of putting the heating cooling system and equipment and the ducts in the attic that's unconditioned is something we got to shut that down. That just in all climates doesn't make sense. So this is what we have to watch the most. And then when I do the red line test for air barriers, this is a typical house with a vented attic, and a red line test, you basically draw a line on the air barrier and never lift the pencil up to make sure you have the complete air barrier. And notice the inside air barrier is fine, but my exterior air barrier is got a problem. Oops, we have no air barrier in the top side of the insulation. And I'll tell you, I installed 24 inches of cellulose in my attic right after I moved into it. And when I went back 10 years later to go up there, it was down less than half, compressed down. And when repair people go in with cable or whatever, they walk through it, your fluffy stuff in the attic is really difficult. The reason they require the codes levels to be so high is because it is such an egregious interface. And then we stick the heat and cooling up there. What are we thinking? So I'm going to submit. It's time to stop the insanity. We have to go to unvented attics virtually in all climates. It's just going to be a superior user experience, right? All the added volume for MEP, for living space, for storage, whatever you want to make it. And then you have more comfort, because instead of having 160-degree temperature right above me today in a Phoenix home, I have about an 85-degree temperature right above me. And the surface temperature drywall will be a whole number of degrees cooler, and surface temperatures dominate comfort. And then I have more efficient performance. I have greater storm resistance because if I have a vented attic and the air can get through the vents and create pressure in the attic and blow up the whole framing structure, that's greater risk. If embers during wildfires can go through the vents and ignite the framing, that's greater risk. Unvented attics are far more resilient. The only issue would be in cold climates, severe winters, snow accumulation, having the icicles at the edge, the ice damming would be a greater risk. So you put an air gap between the top sheathing and then another sheathing layer for the roofing. Okay, then comes thermal flow control. The best practices are basically you got to get the right quantity of insulation, the right quality of installation, and then minimize thermal bridging, really good windows, and radiant barriers really factor in with low E windows for the most part. But the big focus, the real thermal performance killers are your quality of insulation, installation, and thermal bridging. Those are not forgivable. And when we take an image of a home today, thermal image, you're going to have greater accountability. Cameras that used to cost $30,000 cost $500 or $600, and they are emotional, immediately understood ways to expose defects in the thermal enclosure. You have to get them right. And even if we reasonably okay, just the framing alone is where you don't have major defects, is far too much thermal loss with conventional framing. And just to give you the numbers, conventional framing, about 25 to 30% of the wall is just contiguous wood. So your R value is 3.5 to 5.5. If I go to advanced framing, I'm almost 20% framing factor. So about 1/5 of the wall is R3.5 or R5.5, let's say with 6-inch framing. If I go to staggered studs to minimize thermal bridging, I'm still 12%. Double wall framing is still 10%. SIPs will get you to 5%. So will insulated concrete panels will do even better. And rigid insulated sheathing with continuous outboard insulation will get you to 2%. I'm going to say the time is up. Every home should be built with 5% or less thermal bridging. There's no excuse. Even when we had go back, I'm not going to go, I'll go back. Even with conventional framing, or that's just too much thermal bridging. So this is what I want to emphasize. That's where everyone should be. And you also have to have militant control of air leakage when it comes to moisture control and moisture risk, because look at the impact that just a 1-inch hole has on a 4x8 piece of drywall in both hot, humid, and cold climates. In a hot, humid climate, if we have a 4x8 sheet of drywall with a 1-inch hole, we have 7 quarts of water passes through during the cooling season. And in the without the hole, only 3/4 cups pass through. So it means 10x greater vapor flow goes through when we have a 1-inch hole than just with diffusion. That's a huge amount of risk in a hot, humid climate. In a cold climate, it's 100 times more vapor flow, airflow going through a 4x8 sheet with a 1-inch hole than without. You have no drying potential, and you have all this wetting potential. Again, air leakage, air leakage, air leakage. You need a really comprehensive air barrier assembly. So that brings me to faster, better, cheaper, right? I just go out of my mind when I look at the risk we take on with conventional framing, thousands and thousands of pieces of wood and nailing and details. And when you have just a simple set of panels that have probably 1/5 the amount of wood, probably double the strength, and you don't have to spend weeks doing the framing. It's faster framing. The air sealing is just the panel joints that have to be sealed, and then the plates have to be sealed on top and bottom. Hardly any air barriers, hardly no attic venting. You have drywall going up faster. You don't have to line with any framing. You can go whatever it takes because you have a nailing surface contiguous on all the exterior walls. So you have less waste and less time installing drywall and trim. And then it's better. It's consistently airtight. Consistently 1 air change per hour or lower is the numbers I'm getting from the best SIP manufacturers. Inherent quality insulation, amazingly airtight without any risk. All the risk of how they're installed, dimensionally accurate, greater resilience, stronger enclosure, added condition space with all that attic volume that you now claim. And it's cheaper because the cycle time is factored in, if inspections are factored in, if all the rework you don't have to do and all the waste that you don't have is factored in, all that more than compensates for the cost difference for the SIP enclosure. So to me, that's an amazing benefit. Let me just give you a sense of just the value of just the time savings alone. When we do a normal construction, we have the design engineering. It's the same if you use something like SIPs. And then you have, then you start the construction process. You do the foundation. When you're doing normal site build, you can only build a foundation and you can't build the enclosure. But while you're building the foundation, you can also build your panels and have them ready to go. And then when they install, it's just assembly of panels versus all the construction you have to do with site build. So it's less time. And then you have hardly any site restoration to do compared with field construction. So let's say that 16 days of savings, $500 to $800 a day is the average carrying cost for a builder for every day the home sits and can't be sold. So that's about 8,000 to 13,000 of additional value cost savings just from time. When you get a bid package for SIPs versus a framing package, you have nothing in the line item that has that $8,000 to $13,000 in it. It's a completely different comparison when you look at all the costs. The average cost variance for builders from an EEBA study was almost $2,000 and high as $7,000. And 1/3 of that was due to poor construction documentation. That risk almost goes away when you build with something like panelized construction and SIPs. You have all these extra warranty calls because you have less customer satisfaction in framed homes. And if I can reduce the number of average number of service requests from 15 down to 9, 6 fewer calls adds up to $1,500 of cost savings just on service calls. And on cash reserves, the average builder keeps almost $4,000 per house. You could say, I'm sorry, $4,000 per house with just a 1% improvement in quality. I'm going to easily suggest that the improvement in quality with all the inherent advantages of the panelized construction could be 3, 4, 5%. So now we're talking 12 to 20,000 savings there. And so then there's just the aggravation and risk working with trades. Think of all the trades that go away when you use SIP panels. You have exterior framing you don't need. Many manufacturers will also do the interior framing and the exterior framing. The insulation contractor goes away. The air barrier contractor work goes away. The air sealing work goes away. And the trade work that's reduced, the interior framing, the drywall I mentioned because of all the savings on the exterior walls, the finishes with absolutely dimensionally accurate wall systems that require less rework and adjusting. So all those savings happen. And then the waste side, when I see construction bins like this on job sites, it's just frustrating how much waste there is. And if there are 3 dumpsters and it's $380 per dumpster, which these are older costs that have gotten much higher, that's over $1,000 of additional costs just to get rid of waste. And then what's the value of all that additional volume that you gain? Let's say I have a basement home in a colder climate. I could trade off the basement for an upper level. This is a different example. I can add an upper level volume to a home, and I may have, let's say, another 800 square feet that's retail value of $300 a square feet. You know, very quickly it's $160,000 to $200,000 of value. And then the value of not having to do that attic ceiling interface. I don't have to do the air barriers, $1,000 to $2,000. I don't have to do the attic venting, $1,500. I have all the waste I mentioned, 1,000 or 2,000 that I save. And if I'm saving 3, 4, or 5 days, that's another $1,500 to $2,500. Or I can actually trade off a basement with a shallow frost protected footing and capture that volume as the space that makes up for the basement. I trade off the basement for above grade space. And so again, I save all those costs on foundation, wall framing, air barriers, air sealing, venting, attic venting, waste, time. And then I have maybe above grade space that's worth, let's say $250, $300 a square foot compared to a below grade space that's worth $100 to $125 a square foot. So that's worth $60,000, $100,000 more. It's really important that we think through completely the entire ledger of debits and credits with all the choices we make on the enclosure to get to our optimized choice for faster, better, cheaper. So why isn't this happening? So I want to talk about the innovation challenge. How am I doing time, Jack? Oh, how much? 14 minutes. Okay, I want to get to Jack, but essentially, I want to just explain the challenge is essentially this. Everyone thinks this is the market diffusion curve, and this is a myth. You go very smoothly from early adopters to mainstream users, and then you have the laggards that finally come along and embrace innovation. In fact, there's a reason why the early adopters don't adopt. They're not, they do adopt. They're venturesome. They're willing to take on change. They cope with uncertainty. They don't worry about setbacks. They'll figure it out. They form innovation cliques, and they're excited to kind of figure out the challenges. And they're really willing to gamble on the future awards, when the mainstream users, not so much. They are very discreet use of new ideas. You gotta prove it to me. You need very extended deliberation. They resist uncertainty. They only do proven solutions and whole products. That sound like a lot of builders, you know? And then you have this chasm, which is the reality. You don't smoothly go from the from the early adopters to the mainstream users. It's so hard to go because they're completely different audience and a completely different sales process. And so when you don't cross the chasm, you go flat. Think geothermal, think SIPs, lots of new innovations don't make it across the chasm. And so what we've been proposing with SIP and SIPA and the board and all the members is a comprehensive strategy for addressing all those challenges with the mainstream users. The one I want to focus on is this true cost bid package, and I'll hand off to Jack. I'm going to skip this. So the true cost bidding package, what we did is just take that faster, better, cheaper.
FYI, there's some printouts of this up here on the front table. If you can't see this, you can download it from the website. But if you need some visual help, there's some comments.
And all I want to show you is in the upper left, you have cost assumptions that are laid out that drive the analytics for how you get true cost. And on the right are the value assumptions that drive the analytics for how you get value calculations. The idea would be this would be a cover sheet to any bid a SIP provider would give that would help provide a comparison to the framing package bid that will be coming from someone else. Get ahead of the fact that the builder will be in shock seeing the higher maybe SIP price compared to the framing package. And then the calculations below are done automatically and when you put in certain information. What I want to really get to the point before I hand off to Jack is that when I took an actual bid that one builder got and gave me for a SIP package and a framing package, and I just took the package as it was given and put it in the tool, SIPs was almost $2,000 more expensive. Then I ran the tool where I counted for time. I counted for less risk. I counted for less work with the drywall. I counted for less work with the trimming. We added all these factors in, and if the builder doesn't agree with the amount of savings, you can in real time make any changes and do adjustments. But what happened is instead of being almost $2,000 higher cost, it wound up that the cost for SIPs was over $13,000 less, and the added value added up to 13. So the total benefit to the builder was over $26,000. And this is what, I love the presentation this morning from the ASU professor, and he showed and said, we got to get lower costs for renewables. And I kind of was screaming at the screen. I was kind of screaming at the screen. We don't need lower costs for renewables. We need true cost accounting for renewables, just like we have for the SIP package. We spent about $6 trillion in the last 30 years or so protecting the shipping lanes for oil shipments. We spent easily $8 trillion for military investments where we have strategic interest in protecting our oil sources. We spent billions of dollars in cleanup. We lose tremendous amount of jobs in the economy. We spend hundreds of billions of dollars on health costs because of the factors in air quality and how they impact health. I can keep going on. All the costs that you and I pay that are not counted in a gallon of gas or a ton of coal or 1 million cubic feet of natural gas are shocking. I mean, natural gas fracking is destroying how many billions of gallons of potable water? Where's that cost factored into the cost of gas? So he was saying we have to reduce the cost of renewables. No, we have to do true cost accounting. And then renewables will be insanely more cost effective. But this is the same thing taken down to a very much lower level. I'm going to let Jack now introduce the state of the SIPs.
Thank you, Sam. I appreciate that. So really, real quickly, and once again, for those of you that are interested, I know it's an eye chart. There's some little copies up here on the front table if you wanted to just get a summary sheet of how the iterative tool works. A little bit of discussion too about the tool. You can go to sips.org, you can download it actually from our digital resources, and it's there. Where you can download it and have the permutations yourself. We're in the process of actually making an online app. So you'll be able to put in your cost solution for whatever wall assembly you use. And then you can compare that to a SIP assembly and have some real time discussion there. What we really encourage you to do though, is not necessarily do it on your own, but we have 3 or 4 SIP manufacturers that are here today. So whether it's Extreme Panel or Energy Panel Structures or Intercept, a variety of those companies are here. So the idea is to sit with one of them and they can actually help compare one to the other where the savings are. So you don't necessarily have to kind of believe us, you can use your own numbers. But with that in mind, the big green one. Just real quickly about where you can get more resources on this. So the structural insulated panel, SIPA, like an association similar to EEBA. We've not been around quite as long as EEBA. I think EEBA is around 5 years longer than SIPA, but 1990, and essentially it's the organization of all the manufacturers. So there's about 25 manufacturers in North America that produce almost 20 million square feet of SIPs. The association works to do all of the code work, the detailed analyses for proving that SIPs can work in all the seismic zones, that they can work in the high velocity hurricane zones of Florida, that they have low embodied energy and all the carbon studies. So that's really what the association is about. If you're looking for experts, either for sales, for design, for installation, for calculations, you can go to sips.org and under find experts find that. Additionally, there's the bottom bullet there, over 600 really great project case studies. So very similar to these designs on the wall here, you know, every year 4 or 5 SIP projects actually win the DOE awards. But you can go to sips.org under projects and you can search the projects by state, by awards, by HERS rating. There's over 100 projects that have HERS ratings under 45. Passive house, lead standard, air changes per hour. If you want to say, show me SIP projects that have an air change per hour of less than 2 or less than 1 or less than 0.5. Show me the passive houses. They're all there so you can follow those. Additionally, we put together a brochure, a set of brochures, but one of them's called Building with SIPs Need to Know. So if you've never built with SIPs before, and once again, there are a few of these documents on the front table here, but in the spirit of digital and downloading and you not having to have 1,000 things in your suitcase when you fly home after this conference, you can download it for free on the digital resources at sips.org. But essentially what this brochure does is it steps through kind of 10 buckets of, so you're new to SIPs, what would you need to do differently? And then in the back, there's a checklist of the 10 things that you need to do and some bullets underneath of them. What we've done from there, as you can see on the bottom part of this side, is we've taken each of those chapters and we've kind of done a deep dive. And so if you want to get into the geeky building science of how do you do HVAC with SIPs, we got a 12-page brochure for you. If you want to know how do you do electrical with SIPs, we got about a 6-page brochure for you. If you want to know how to do just high performance building enclosures, there's a brochure for that. So you can step your way through and go further. Here's a screen print of our website at sips.org. So structural insulated panel, kind of plural, SIPS.org. You can go there in the red bar across the middle third there. You can see things like SIP projects that I spoke about earlier, the second item. You can find your SIPs experts, the fourth item or third item over, news and events, but all the way over to the right, there's a design professional button for engineers and architects. So everything you need to know there. For builders, also some information there. And resources essentially is just topically where you can find things like, well, what about SIPs with seismic? Well, what about SIPs with fire? Well, what about SIPs with termites? All that data is there. Sustainability information, life cycle information, all that's available for you. Additionally, under resources is the education piece. And we call it the BEST training program, BEST, Building Education with SIPS Training. And so you can actually go through 10 1-hour little videos by a gentleman named Al Cobb. Let's put those together. And they're AAA certified. You can get health safety referral credits with them. But if you take all 10 courses, you take all of the 10 little tests, you can become a registered SIP builder. And then once you actually build a SIP project, get it HERS rated, get it indoor air quality tested and blower door tested and show that you can meet the requirements, then you can become a master builder. And so that's available for you there as well. So essentially, Sam and I are at your disposal, but more importantly than us, the companies that are out there, there's about 6 or 7 SIPA member companies that are there. So whether it's the BASF guys that make the foam, the DuPont guys that make the glue, the OSB guys that put it together, and then actually the SIP manufacturers. So like I said, Extreme Panel, Intercept, EPS, there's a variety of them out there. So feel free to drop me an email or Sam an email. You can take a photograph of this. You can go into the Hoova app and contact us via Hoova. And with that in mind, we probably don't have too much time for questions. So yeah, we can take a few questions, and we're going to have the cocktail hour as well. Yeah.
I've neglected to say, by the way, if you want CE credit, make sure to go in the back of the room and get that set up. Thanks.
Exactly. Ted Clifton, who built a great SIP home that just won an award, is here. Also, Clifton View Homes or TC Legend Homes, also another SIP home. They win them every year. You can go to the Tour of Zero website that Sam used to run and see all the detailed information there. But pleasure talking to you. And if there are any questions, we have a roving mic, or you can just come up and talk to us one-on-one. Thanks. The roaming mic.
Any questions? Well,
They're like ready to drink.
I'll
me.
just add, Jack made me drink the Kool-Aid and Sam made me drink the Kool-Aid, and I just am completing my first SIP project with our friends at EPT. And we framed 54,000 square feet in 15 weeks. And I'm not kidding. We had 6 weeks of weather delay down there. And there's some other pieces that I helped with the committee on the total cost, but I live in the prairie of Minnesota, in a little house on the prairie. They're not kidding. This is flat. Most of the wind power is up on Buffalo Ridge right there. What I didn't realize, one of the other benefits was at 55-mile-an-hour winds most days. I have security footage of 2x4 12-footers blowing around my job site. And the SIPs are just up there. We didn't have to brace them in place. It was so quick, so easy to put in. It was just incredible. So if you haven't looked at it, it's definitely worth taking a look. So hats off. Sam, please.
So on top of the strength, though, if vapor flow and airflow are virtually going to kill the performance of your whole home, and you have an option that has no pathway for vapor flow and airflow, it just, at some point, we have to start thinking, why are we not looking at least seriously at a real cost comparison? And like I said, I'm not a SIP manufacturer, but I just go, I need to really have the real numbers. So just if you all do that, at least that would be great.
But I just add, I want to keep it. I don't mean to do a commercial, but I apologize. Like, how hard is it to get labor right now in the marketplace, right? I mean, it's just difficult to find guys, to find crews, to find framing crews. And so not only those numbers I told you before, but we did that with 12 guys. Now we had a crane a couple days. And by the way, those crane guys have it made. But I had 12 framers out on site that framed 54,000 square feet in 15 weeks with 6 weeks of weather delay. That's incredible. So talk to the team, talk to Jack. Jack's such an incredible resource, and we're so happy to be partnered with SIPA. That Certified Master Builder SIP program is also on the EEBA Academy site, and you can take it there. They've been generous enough to share that with us. So just a couple housekeeping. Thanks so much to both of you. We have the cocktail reception next door. That'll go from 4 o'clock until 5:30. I believe we have 10 tickets left tonight. We're going to go to the Walton Center for Planetary Health at Arizona State University. The chief architect from the university will be giving tours of the property. I always find there's so much great information I learned from our brothers and sisters in the commercial side that I can bring back and apply to residential. So we're really excited to take those of you that want to join. You can buy a ticket upstairs at the desk, and we'd love to see you there tonight. That'll be from 6 to 8. I believe the buses will leave right about 5:30, 5:45 from upstairs lobby. So thanks so much. We'll see you in the reception.